Well, I left myself a fair amount of room to fill in this matrix, but I might not have left myself enough. Let's see. Okay, so what's being pumped in here? This is being pumped in with a concentration. Q2 over 80. Then we could say that over 80 gallons. We'll eventually, I say, suppress the units, but let's keep them for a minute just to make sure that everything meshes, that all the units make sense. Okay, so it's Q2 over 80 gallons. Okay, this is, now it's Q1, the quantity of solute in here, over the amount of stuff that's in the tank, and the first tank's initially empty, so the volume of this tank is going to be a function of time. It's going to be a simple function of time. It's going to be a function of time. So this is,
Hanging out, huh?
Yeah, the door's not open.
I'll just write it out here, didn't leave myself a lot of room. Again, Chalk's being a little bit uncooperative. I just don't know how to control the thing. But that's Q1 over V1 of T, whether you can read it or not, okay? And V1 of T, because we know that V1 is going to be changing in time, okay? And then what's our what's the concentration here? Well, that's the concentration here, and it's also the concentration here. You know, this is what's coming out of the second tank. And similarly, concentration here is Q1 over V1 of T, which is the same thing that I wrote up here where I didn't have room. Okay? So, at what rate does the concentration in this tank change? Due to the Q1 and Q2, because we've already got the rate at which it changes according to the, as a result of the, what's being pumped in, right? But down here in what's being exchanged, well, what happens to Q1?
Like what's going in or what's going out?
Well, total, what's going in, what's going out.
Okay, you got coming in from the tank 2, you would have Q2 over 80 times 4 gallons per minute.
Yeah.
So you'd have.
So that's going to go where in the matrix? Well, it's a rate. It's contributing to the rate of change of Q1, right?
So top right.
It has to be in the top row. Okay. Because top row is going to ultimately give you the rate of change with respect to Q1. Q prime is Q1 prime, Q2 prime. Q1 prime has got to be whatever's in the first row here. Okay? Plus whatever's in the first row here.
So
okay.
Q2 over 20, we'll get in the top right.
Q2 over 20.
Yeah. That's the rate at which the cell uses.
Okay, yeah, you're just doing the multiplication.
Yeah.
Okay. Yeah, it's 4 gallons per minute times Q2 over 80 gallons, right? So I'll make a note of that down here. Four gallons per minute times Q2 over 80 gallons is Q2 over 20, okay? It's actually in units of reciprocal minutes, meaning per minute. Okay? That's the amount of solute per minute. So that's what we get. That's what's going to go here because it's going to multiply the capital Q2. So we're going to put Q2 over 20 here.
You just need 1 over 20, right? Because you're going to multiply that.
You're right. We need Q2 over 20. So it's 120 per minute. Okay? 1/20th of a unit of solute per minute. And that's, well, times the amount of solute in Q2. And that, the units get a little complicated, so I'm going to start suppressing them. Don't want to worry too much about it, but you want to think it through to make sure the units work out. Okay, and then over here, what goes out? Well, 2 gallons per minute at concentration Q1 over V1 of T. Okay, now, what is V1 of T?
6T.
Okay, because you got 5 gallons per minute coming in, 9 gallons per minute coming in, right? 5 and 4. And minus 2, which is 7, going out, minus this one, which is 6 going out. So V of T is 6T. Okay, so we can then write this as two gallons, well, okay. We've got 3 gallons per minute going out. Okay, and that all depends on the Q1 over V1. Okay. So we have negative three gallons per minute over 6T. Okay, negative 3 gallons per minute divided by the volume, 6T. We multiply that by Q1. Okay, that should be pretty clear. Okay, then what do we have for the second tank? Coming in, we got 2 gallons per minute from this one. And going out, we've got 5 gallons per minute of whatever this is, right? Now this tank is full, so it's always 80 gallons. So we have 2 gallons per minute times Q1 over V1. So it's two over 16. That'll be multiplied by Q1. And then here, going out, we have 5 gallons per minute of this concentration. This concentration being Q2 over 80. So it's going to be 5 times Q2 over 80, which is going to be minus Q2. Well, it's going to be minus 1 over 16. And we can easily work that out. Okay? So now we have a couple of time-dependent quantities. So we can kind of look at this generally. So now the question is, okay, initially, V1 is 0. It might be better to start this with a little more than 0. The example in your book does. Because it's impractical to start these pumps when you don't have anything in here, even though something is immediately going to come in. Okay? At least this pump needs something in here.
Maybe the pumps are hooked to the bottom, or maybe Maybe
Yeah,
all the
well,
outflows on the
you
bottom.
can say instantly there's gonna be water there, so you're gonna be able to pump it. Now, very quickly, there's enough water there to get the pump. So maybe the pump is primed, you know, we're not gonna worry about that, we just wanna look at the process, okay? But typically, you would have a little water in here, and that would just add something, you know, if you had a gallon of water in here just so you could start the pumps, then your denominator would be 6T plus 1. Right? Your volume would be 6T, which is the amount that's come in T minutes, plus whatever you started with, okay? So anyhow, initially V1 is 0. And that's really okay, we do have a problem with that mathematically in that this denominator is initially going to be 0. Okay? So I'm going to change things a little bit. I'm going to say, okay, we got a gallon in there. So now your denominator is 6T plus 1. So we don't have a singularity. So initially, V1 is 1 gallon of water. And of course, T equals 0. So what's Q prime?